Well, hi, and welcome to my shop here on March 6th, a day which is above freezing here. Oh my gosh, in fact, it's crazy. It's going up to 10 or 11 degrees today with sunshine, maybe some rain. And we've been in the ice cooler, the cool ice box. We've been in the ice box for the last couple of months. Typically minus 10, minus 15 degrees. Today is an outlier. Tomorrow it gets cold again, like minus 5 or something like that. So, well, along with the confused weather, I myself might be a little bit confused about the videos I'm posting, because I'm doing multiple projects at the same time and trying to make videos of this kind of stuff. And so if you're watching my videos one after another as I post them, well, thank you very much for watching them. And if you're one of the people who's clicking the like button, thank you very much for that. That's very encouraging for me, very helpful, so I really appreciate that. But I may have gotten myself confused in the morass of video segments that I'm piecing together to make these videos. So hopefully I haven't done that, but I'm no longer sure. And talking about being sure, that's what this video is going to be about, at least to start. Trying to be sure that the problem in this radio is what I suspect it is, which is an alignment issue. To be a little more specific, the FM reception's poor in this radio. The volume output is very poor on FM, but not on AM. It's fine on AM. So what is it about the FM side of things at the end of yesterday's shop session with this radio? I felt pretty sure it's the alignment that's off, and I could very well be right. But what I want to start with today is a little more experimenting to try to prove to myself that the alignment is off. Now, we can think of alignment as a process of lining up the ducts all into a nice row, but another part of it is getting that row in the right place. So we can also take this radio and we can split it into two parts. There's more than two parts in here, but we can split it in two parts for the purpose of what I'm doing here. We have the FM receiver up in here, up in this box, and the output is on this cable, and it comes down into this part of the radio, which is the IF part of the radio. And we can think of this as one thing and this as another, and the question is, are those things lining up properly? The lane they should be on is 10.7 megahertz. There should be a 10.7 megahertz signal coming out of here, and these guys should be ready to receive a 10.7 megahertz signal and do what they do with it, which is basically they're involved in the amplification stages of the signal at that point. So of course it's coming in on the antenna at 100 megahertz or somewhere around there, depending upon what station you've tuned in. Converted down to 10.7 in here, and then shot through here, and then further converted into audio right at the end here. Now I've had this radio on for 10-15 minutes to warm up. I've got this guy warming up also because we're probably going to employ him. But the very first thing I want to do is utilize a simpler signal generator, and that's this guy here. You see, I've got it dialed up to roughly 10.7. It's very close to 10.7. And what I want to do is I want to inject the known frequency of 10.7 into this radio and see how it proceeds through the circuits. This is my idea. What I'm thinking is what is coming out of here is not the 10.7 signal, or a signal centered on 10.7. That's really a better way of putting it. It seemed to me from my experimenting and testing yesterday that this was off. So one way I can kind of prove this is by feeding a known 10.7 into this point, having it work its way through the rest of the radio and seeing how well it comes out. Well, then I can vary that 10.7 up and down a little bit and see if the signal strength goes up or down. Now, this is a little bit tricky business. This is not an FM signal generator. There is no variation in the frequency. So exactly how well this is going to work, I don't know, because I don't think, well, a really good FM radio will not respond to amplitude modulation. It uses a simple technique of cutting off or limiting any variations in amplitude in the FM signal right at the end here. In most, certainly in newer FM radios, and that's how it becomes impervious to amplitude modulations such as static, lightning crashes, and other things you typically hear coming out of an amplitude modulated radio, an AM radio. That's how come FM is so quiet. It has to do with the limiter up here. Which, by the way, if your FM signal gets weak enough, if you pick up a weak station, you start hearing all that noise again because it's not getting limited. It's not strong enough to reach the limits that are set up by some circuits later in the radio. So only impervious on strong FM signals. Yesterday I was fooling around with the SDR. I got some very interesting results with it. I was very excited, in fact, because once again the SDR is helping me reveal things that are going on in the radio that are very hard to get a grip on. And the last part of this challenge is, as with any testing, when you hook up the test equipment, you can cause a change in the circuitry. The higher the frequencies you're working with, the more apparent this problem can be. And apparent isn't the right word because it's actually not terribly apparent. It's very tricky, in fact. When you hook up a piece of equipment, you've caused the radio's operation to shift a bit. You don't know that because you've hooked it up and the shift has happened simultaneously. Maybe then you do some work on it, aligning it or whatever it is you're doing. And when you remove the equipment, the radio goes back to the way it's really intended to operate, and the result isn't that good. But it was great when I had the equipment hooked up. This is actually very tricky to avoid. Now, if you're a younger person than me, if you're from the modern era, working on digital equipment, almost everything has digital circuits in it. Almost all that operates with square waves, essentially. Square waves have very high frequency components, and if you've gone through school to learn to work on that kind of stuff, or you work on it now, you've become very comfortable with this problem that I'm talking about because of the high frequencies involved. So you might be scratching your head and wondering, well, what's the big deal here? Well, us older school guys, and by the way, I went through college right on the fringe of this, right as digital circuitry was coming to the fore, and this kind of stuff was fading out. Tubes had long since faded out, but analog technology was fading out. We're not necessarily so comfortable with this problem. For me, it all comes home to roost with FM radios because of the higher frequencies involved. The lower frequencies than an AM radio, excluding shortwave for a moment, just a regular little AM radio, you can get away with a fair bit of bad, well, let's just say the things you do on those radios, which will work fine, may not work well on other higher frequency radios, higher end shortwave radios, and FM radios, and then all the digital stuff, which of course there's nothing digital in here. Okay, having given a nice long speech, let's see what I'm going to do. So I'm going to attempt to hook up my signal generator with a 10.7 signal. I'm going to try to feed it in at this point, which is the output from the front end tuner. Feed exactly 10.7, have it go through the radio, hope there's a response that I can pick up somewhere. One possibility is I may have to plug in the Magic Eye tube. I have a brand new Magic Eye tube, brand new, well, NOS. I'm not even sure it's NOS actually. Plug it in, and I may have to use that as the instrument for determining some things. There's other alternatives, but I have to fiddle around a lot to make those work, hooking up meters and stuff like that. Or looking with my SDR radio, which is probably where I'm going to go, come to think of it. Now, just putting this on here may already start disturbing things. I'm not sure. I've also pulled out the FM tube, so the FM receiver is not going to interfere with what I'm trying to do. Got it on FM, turn it up loud, There's nothing, because this tube is out. Now, how do I hook up my signal generator safely to this radio without running the risk of basically upsetting the whole circuit and getting into the false testing zone? I don't know. I'm gonna do what I would do, and we'll just have to kind of be vigilant here, I think. So I think what I want to do is have a small capacitor on the live side of this. Now, there already is a fairly small capacitor involved in this back yonder, but I think I want to stick another little one here. Now, how little? The littlest I've got handy. The littlest I've got handy. This isn't all that little, but it's something. I'm going to use this because it's got clip leads on it. Volume's up. What do we hear if we just touch this? Oh, starting to act as an antenna. Let me get you just a little bit closer here. Because I'm doing multiple projects right now, and that's because the demand for me has shot through the roof here. This is supposed to be a sort of a semi-hobby thing I'm doing, but I am getting calls from people every day now. Can you fix my this? Can you fix my that? My radio doesn't work. What do you think it is? I get calls like that. So we're going to put this on here. Okay, well, we're going to attach the ground. This radio is plugged into an isolation transformer, so this shouldn't be too exciting. No, not exciting at all. I think I shorted to the live side, or the signal side, we can call it. There we go. Put this here. Now, what kind of signal level do we need on this? I have no idea, so I'm going to start with a very low signal level. Volume is very high here. Let's turn it down. Okay, nothing bad happened. Nothing happened at all. Turn it up. Now this is a modulated AM signal, and as I was explaining, there's a good chance we'll never hear it coming out of this radio. We don't hear it now, but the signal level is very low. I imagine there's a fairly good signal here. It's got this two-part tube. You can actually look inside, and you can see it's two separate. There's a left and a right, and there's a shield plate in between, in the middle. It's two tubes in one. We're going to up the power here on the signal generator. See if we start hearing something. 1,000 hertz. Here we go. Well, I can hear it. Okay, fantastic. Excellent. Okay, so this is going to work. Let me just calibrate this for a moment. Oh, it's way low, way low, way low. This gives me some notion as to what the signal level is reaching the end of the wire here. Way off. 400 and 1,000 hertz tone. Excellent. It's a very low level signal. Not much at all going through. Yeah, I guess the signal coming out of here would be quite low because the real amplification takes place up in here in radio. Excellent. Now, the question is, this is very close. Well, it's pretty much 10.7 here, which you can't see, but you'll have to trust me on it. I'm going to vary it and listen if the signal gets stronger or weaker. If I remember right, yesterday it appeared that what was coming out of here was below 10.7. There we go. Going down first. Okay, so the FM response isn't a nice simple hump, right? It's a small hump, big hump, small hump. I think that's what we heard. I'm going to go up now. I'm at 10.3. I'm going to go up. I'll stop at 10.7. Oops, I went by. Okay, so this is 10.7. The variation in the volume isn't all that great. Now I'm going to go up. see what happens. Goes down. Okay, I'm going to close my eyes. I'm going to turn that signal generator, listen to the volume, and spot the maximum just by using my ears. And then I'm going to look over at the frequency and see where you ended up. I would say that's the loudest there. I should really have a meter on this doing it, but 10.568. Oh my gosh, that's just totally different from what I was expecting. Let's just keep working on this a little bit. Go back up to 10.7. Okay, I'm up at 10 point here. I'm gonna put there's nothing much to see other than this numbers changing anyway. So I'll let you watch these numbers and listen. Okay, so what I'm getting out of that, I'm getting two humps. The hump to the right seemed to quiet the radio more than the hump to the left. This is the hump to the left coming first, the lower frequency hump. Okay, right there. Did you hear a fair bit of background static? Now we'll go to the next hump. Peak. Well, it's right around 10.7, and now we'll go up. Where's the other hump? Where's the other peak? So we're not getting this classic up, up, up. We're getting a up, up, 2. What does that tell me? Well, the circuit that we're listening to, the circuitry we're listening to is everything beyond the tuner here. We're listening to all this stuff. No reason to think it wouldn't behave in a typical or standard way unless there's something cockeyed with it, or my connection to the equipment here has made it cockeyed. It is possible. The signal generator itself is very low impedance, 50 ohm output. So I'm bringing out basically a 50 ohm load, if you like, onto here. And it could be quite different from what this box itself has here, almost certainly. Am I proving anything here? Now, of course, there's another thing going on here, and that this could be out in terms of its alignment and tuning, and this stuff could be out. They could all be out. And so, if I look here, I find a problem. If I look there, I find a problem. But what I'm trying to do here, I guess I haven't been totally clear, is I'm trying to avoid unnecessary alignment monkey business with the radio. Okay, the next wisest thing I can do from here really is read the alignment instructions for the radio, and I've done quite a few like this now. One of them I really spent a long time on. So I think it was almost identical to this radio. So I'm not unfamiliar with this, but I sure don't have my 10,000 hours on FM, that's for sure. Okay, so I'm going to stop, I'm going to read the alignment instructions, maybe I'll pick up some hints from that before I do anything more with the radio, and kind of accepting this observation for what it's worth. I don't know what it's worth though. Okay, maybe talk. Okay, here's the alignment instructions for the radio, which I hope to go through, and this upper part is for the AM alignment. Many steps here. Surprising to me, it's an awful lot of steps just for the AM. The FM starts here. I'm going to zoom in on that part so we can read it more easily. So we have two or three different ways of aligning this radio. This first one is FM IF alignment using AM signal generator and VTVM, vacuum tube voltmeter, selector and FM position. What I found here, which I think is pretty interesting, is how they recommend injecting your test signal into this radio. And the hint is right here. Signal generator coupling, high side to ungrounded tube shield over FM converter. FM converter tube is what they should say there. Low side to chassis. So what they're saying is I should slide a tube shield onto the ECC 85 tube, the one I have pulled out right now, and then attach my signal generator to the tube shield, and that's going to leak enough signal into this tube. It's going to go in the radio, and this is how you do it without disturbing the operation of the radio too much. So I'm going to do that and repeat the test I just did. And I haven't read the rest of this. I just glanced at it. It's like all these FM alignments. It's not easy. It involves making little circuits up and attaching it to the radio and other stuff. So I won't sweat over that. We'll just do this one step at a time. And that'll keep me from literally breaking out in a sweat here. Okay, so I'm going to detach. And almost certainly those instructions are in order to not disturb the radio you're trying to test. So I'm going to put this tube back in. Very carefully. There we go. And find a tube shield that's going to fit on it and do the job. Let's see. I have lots and lots and lots of tube shields. Now, this tube already has a shield right here, this metal part, but this part is grounded to the chassis. So they're saying an additional tube shield, but it can't come into contact. Got to be a bigger tube shield than that. It can't come into contact with the. Can't do that. Can't be touching this other shield. Once again, easier said than done. That's the baby right there. Like this is actually get down past the this shield without touching it. Yeah, that's perfect. It's the simplest tube shield I've got, I think. It's just a piece of flat metal. Okay, now we'll hook up a signal generator there. See if we get the same kind of result. You might discover right away that what I was doing before was baloney. So the ground lead goes to the ground, goes to the chassis, and the hot lead goes to the shield. You can just imagine this is not going to put anywhere near enough. Well, I don't know. I was going to say it won't put anywhere near as much signal into the radio, but it may, because now it has this tube to amplify it. Turn it up. Quiet as a mouse. Mice aren't that quiet. Just ask your cat. Okay, well, there's absolutely no reception. There's no antenna on the radio. I would be surprised if it did anything when I did the tuning thing here. We're on FM. We don't hear a thing. Volume's right up. So now I'm going to hit it with a stronger signal here. Stronger again. Oh, we're not at 10.7. Oh. Lovely. Let's give it a little stronger. Every time I click that, that's a 10 times stronger signal. Okay, well, I heard the two humps as I went by. Let's look at the frequencies involved now. They could be different. There we go. Way about 11.2. Okay. Take this down a bit. A little too low. Try again. So what I'm seeing is kind of the same pattern, but the whole thing is shifted lower in frequency. So that hissy peak, and then the better sounding peak. So I'm hoping that when we're doing this, it's going to say the problem is here or the problem is in the IF. It's not working out that way. It's interesting observations, but they're not terribly helpful. So I think I'm just going to have to revert to performing the alignment as laid out in the alignment instructions, starting with the IF in the back of the radio here, and just work my way through the whole thing as told by the instructions. Okay. Yep, I got to do a lot of reading now before I continue on. Okay, step one. FM alignment using AM signal generator and VTVM. Connect two matched 100K resistors. 1%. You have to be within 1%. 1% of 100K is 1,000. Have to be within 1,000 ohms of each other. In series from point B, I'll have to find point B, to the chassis. The junction of these two resistors is alignment point D, as shown on the schematic. Okay, well, we'll look at that in a minute. What I've done is I've taken my 100K resistors. You see them all here. And I've tested each one of them, and I've written the results down here. And now only one of them came out to really 100. That's 99.5 there. That's pretty close. They don't have to exactly be 100. They have to be as close to the same, within 1,000 of each other is what they're saying in here. But the closer, the better. So which two of these are really, really close? There's a 97.2 and a 97.7. So that would be 0.5. That'd be 500. Half of 1,000. A 96.7 and a 96.15. That would be 600. So those would do. Let's see if we get something even closer. Well, right here. Oh no, 96, 97, 98, 96, 97, 98, 99. Well, between 99.45 or 99.5, this is about 800 here, so we're doing better with these two. That's quite a game here. How many ways can you arrange the chairs? How many ways can you arrange 10 chairs around a table? So offhand you might say, I don't know, 30 or 40, but if you look into it, the number is gargantuan. Yeah, so how many ways can I arrange these two resistors? Find two resistors here. Gargantuan. So I think I'm going to have to pick these two, 97.1 and 97.2, 97.7 and 97.2 for a 500 separation. That's within the instructions. So that's the third one down and the third one up. That's these two here. Okay, let's double check these. I'm using this instrument to test them because I have faith in it. .67. So that must. So none of these. What's going on here? 96.67. Didn't test the same. Test again. I wish I'd kept these in better order when I took them out of my 96.6. Okay, well let's write it down. 96.6. 2.6, we might still be okay. And 97.02, another different reading. I did test the same resistor a couple of times using different leads. I got this pretty much the same reading every time, but not now. So 97, we're still okay though. 97, maybe it's a small change in temperature as I've been holding them. Did I change it? Let me hold on to this. Well, this thing won't reread. Well, it just reads once. I'll warm this up with my fingers here. Okay, what do you say now? 97.25. So maybe it's just the temperature of the resistors. That's kind of interesting in itself. So these two are going to do the trick though. They are within the range we need. Okay, next task. Investigate this point, test point B. I have to flip the receiver up on its side. I got a bunch of stuff to do here. Okay, get all that ready. Okay, just finished an extended break with my cat. Now, instructions talk about test point A, B, and C. I found them on this sheet. A, B, and C in these boxes. In some of these radios, the test points are actually places you can clip stuff. This radio doesn't seem to be the case. It's just places on the circuit board here. So if we look at, and what's important on this first test is, let's see, DC probe to point B. Before that though, I take those two resistors, solder them in series and stick one end on point B and the other end onto the chassis. So point B. Point B is on this curious little piece here. I'm going to have to solder the two resistors from here to, let's say, a good spot would be here. Okay, that's what I'm going to do first. Put in our test point resistors here. It's very, very, very windy outside today. I'm going to do something like that. That should work. Okay, I'm going to solder those in and get ready to do the first test. Okay, something maybe I should have looked at before I got this far is the actual tool required. The adjustments I'm going to be making are inside here. These are the speaker leads and they're just in the way. Okay. Let's bring it around this way. Okay, speaker leads connected up again. Not that that really, well, we're not going to be listening to the, this is all tangled up here. So I will be using the VTVM meter over here. It's just out of view at the moment. This is the ground lead. The set is not on, by the way. I would not be doing this with the set on. You can see the two resistors I installed are there, creating this test point, which comes down the road. Now getting back to the problem at hand. So this has some helpful hints on what tool to use to make these adjustments. It lists the, it says here, suggested alignment tools, A1 through A5. That's what I'm about to do. Pretty sure. What am I actually doing? I'm doing A16, 17, 18, 19, and 20. A16, so for those, Oh yeah, 16. Wait a minute, I didn't even list them all. 8, 13, 14, 16, 17, 18, 19, 20. Well, it's not in the list. I wonder what's special about all these adjustments. Wow. And then what are the tools? The General Cement number 8282. Yeah, General Cement. Can you believe that? General Cement. I guess there was a time where somebody was running a cement company, and one of the executives said, "Hey, we can make cement. We can make alignment tools." In fact, I think they actually made radios. Kind of funny in a way, isn't it? I guess that's diversification. Okay, so deep in here is a slug that needs to be turned, and it has a small screwdriver type slot in it, and they're way deep in there. And so I think I'm in the slug. Can I turn it? I don't know that this is even the right slug. I just want to check. So the problem with this tool, nice handle on it, but this plastic piece is very twisty. And I'd really rather use something as stiff as a metal screwdriver in there, but that's probably not going to be good. You can get away with a metal screwdriver on a capacitor, but not in these coils. Well, we'll try it with this. Now, which ones of those? Which ones of those? What's what here? So I'm going to stop. I'm going to mark these with what they are so I can't get confused, or at least reduce the chance of confusion. Well, I run into a bit of a problem here, and I cannot find any information telling me which one of these is which. Now, there's going to be a pair for AM here in this box, and a pair for FM, and likewise here, it's going to be a pair for AM, pair for FM. And then there's then it's one or the other. I'm not so sure. I need to do them in order. So one approach here is to have the set operating. Pick one, fiddle with it, see the result, and decide, is this affecting the AM signal we're listening to? And then it's the FM signal, then therefore it's one of the FM ones. So if I were to discover that, say, this one affects the FM adjustments I'm about to do, then it's probably true all the way across the top, and these would be the AM ones. So I really only have to fiddle. With any one of these, as long as I get a positive variation. In other words, if I'm listening to FM, and I twist one of these and I hear some change occurs, maybe in the voltmeter over here, then I know, okay, these are the FM ones. If no change occurs, then I can't be sure of anything. I'd have to switch the radio over to AM, easy thing to do, and then fiddle with one. And what I'm thinking is it might be better to stop attempting the FM alignment and switch to doing the AM alignment. The same problem exists here, but sorting it out might be easier on AM. Oh my gosh, who'd have thought? There's just no information on which is which. I can't extract it from anything in here. It's quite a few pages in the service manual, but I couldn't find a single hint on which is which here. So I think I have to figure it out experimentally, which is which. The difficulty here is, well, let's assume the AM is properly aligned, and I really shouldn't change it at all. I don't need to change it at all. But in the course of doing experiments here, I end up de-aligning it. Okay, well, I can just do the AM process and realign it. But the difficulty could be that with this tool or any tool, there's a chance I can only move the slug in one direction. And the reason for that is well, it has to do with pressure on the tool, pushing the slug a little bit to get the tool to go into the slot, and that encourages the slug to move this way, but discourages it from moving this way, like back out, because you're pushing in with the tool to make contact with the tip in the slot. And then instead of being able to back it out, the tool cams out. It comes out of the slot. No matter what you do, you can't move it back. There's a chance of that happening. Not necessarily a great chance. I have to go get the cement tool. It's either General Cement or the Walsco. You have a long list of tools you could use. So, if this was my radio, I wouldn't hesitate to experiment around. It's not my radio, and I don't want to make it worse. I got danger bells going off in my head. Well, there's bells going off. I assume they're warning me of danger. The best thing I can do is stop at this point and ponder the situation for a while. Give some time. To what? I don't know. To what? To avoid making a mistake. Delay the mistake. That's the idea. Delay the mistake. Okay, just standing here for a minute, I realize there's another option. I don't have to try to move the slug. I can interfere with the radio's operation. I take a little metal screwdriver, like this. It's got a steel shank on it. Just put it in like this. That should influence the radio, and I should be able to tell, yes, that's FM, or no, that's not, without doing anything to it. Okay, why don't we give that a try? So I have all the test equipment going, and the radio's not going. The radio doesn't have to be fully warmed up to figure this out. Okay, is everything safe? Have we got anything funny going on? I've got my DTVM meter connected here. Everything is set to go to do this test. Let's get this wire out of here. Signal generator still on 10.7. No, it's not. It's on 11 point. Crazy here. 10.7. Let me just dial it down. We just need it to make some signal come through that we can hear. Okay, let's give this a try. See what happens here. This is a what would you call this? Non-destructive test, or non-complicating test. Get my hand on the volume control. I think I just turned it down. So we should be hearing the signal generator. Hello. Not hearing anything. Let me turn the radio up. Now I've got this turned around. I get confused about which way's up. So up would be this way. There it is. Okay, we don't need anything other than just the sound. It doesn't have to be good or anything. And we take our interference probe. Anybody? Somebody? Aha. Aha. Not so much. I'm not trying to turn anything, I'm just trying to put some metal in there. I guess these slugs are not down very far. So I can't get this probe in deep enough to affect the coils, but it certainly is working here. Here. Here, no. 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 Indeed, these are going deep. This one's not. Okay, gotta be a Gotta be FM. Gotta be that way. Okay, solve that. Now, do you really need to know which one's A16, 17, 18, 19? Probably not. If I look on the schematic here, sometimes these are listed in order, and they may not really say it. They just do it. So the first one would be A16. So I'm going to look on the schematic. I'll just do it myself here. Quick peek upon the schematic. The schematic, and I'll try to spot A16. Just 1 second here. Let me get my diagrams out of order. Wow, that's just crazy how this is done. So A17 and 18 are in one can, so maybe this one. And A16 and A21. 21. It didn't say 21, did it? It says 16, 17, 18, and 19, and 20. Now, no, 20 is up on the FM tuning box up here. It's probably having an effect on the output from the FM tuning box. FM tuner, really. 16, 17, 18, 19. What's going on there? 16, 17, 18. I must have seen something wrong on the schematic. Oh, it is. I am looking wrong. Oh, wait a minute. This is so 16, 17, 18, 19, and 20, right? Shortest memory in the world here. 16, 17, 18, 19, and 20, right in a row. So I gotta look at another 19. So 19 and 20 are up on the tuning box, up in the tuner. Is this? I'm pretty sure I've got the right schematic here. 18 and 19 are the primary and secondary of a RF transformer that feeds the output. The other test point I was using earlier on the FM box. So that's 18 and 19. And then 18 and 17. Oh my gosh, this is 21's not in this list. 21 comes down here. 21 is done separately, done a little differently. So we have 3 of the 4 being done on this line, and 2 more way up on the tuner box. Then after doing that, we come back and do the 21 in here. So I do have to figure out which one of these is what. Guess would say this is 21, this is the last one, because of its physical position in the radio. It has to be part of the, I'm pretty sure, it's kind of the output side of the second IF transformer. So that would mean I'm doing 18, 19, sorry, 16, 17, these two. Then switching up here to the FM tuner and doing 18, 19. Wait a minute, there's 5 of them here. I'm doing 16, 17, 18, and then 19 and 20 on the tuner. Then I'm rearranging my test equipment to do the last one, 821. Wow. See what it says here. Alignment instructions. Read carefully before attempting alignment. They aren't kidding. They're not kidding. So, 16 and 17 have to be these. Well, it's just possible that these are all perfectly aligned. I don't have any reason to think they aren't just yet. So I'm going to try one of them, see what happens, if I can do it even. I need the cement tool. Oh my gosh, this is tuning. Oh, the slug is as loose as can be. Okay, now, why is my voltmeter now? Well, what are we supposed to be? I'm listening to it. I don't want to listen to it. I want to watch a meter now. Connect VTVM DC probe to point B, common to chassis. That's what I've done. This is point B. It must just be a very tiny voltage. It didn't show up on the meter at all. And what am I trying to do? Adjust for maximum deflection. Wait a minute, is this a DC probe? Adjust for maximum deflection. Okay. You can see the meter here. I'll just make it more and more sensitive. Hey, it's going the wrong way. 5-volt scale. Let's see if that moves when I do this. Oh, it's just moving. It's not even moving a needle width. I'm sure you cannot see it on camera. But you know what? I can hear the sound, and it's matching the movement of the meter here. Oh my gosh. You know, it's one thing to read about doing this kind of stuff, or watching somebody do it in a situation which is simple, or they've worked their way through all the issues and they're just showing you, the good stuff. When you actually try to do these things, there's many ways to do it wrong and only one way to do it right. And I'm particularly good at finding wrong ways. What am I doing? I'm switching the camera here. I'm going to switch the camera here. I'm losing my cool. Okay, this is the camera we want to look through. I just need to prop it up a little bit so we can see the meter. The meter's right above it here. Because the variation in the meter is just tiny. Okay, we'll get this right up close. Okay. Now, I make sure we're at 10.7. We are. Everything is correct to do this. Okay, so going into the first coil, so I've already moved it a bit by accident, so it could be what I'm about to do. See it go down? What I'm about to do is simply put it back to where it was. Okay, so I'm trying to set the maximum. Now doing this on camera, the camera is actually a little bit slow. There's a delay. So I'm going to move this very slowly. Find the high point. That would be the high point. Go back. Oh my gosh, so you know what I did? I just pulled the tool out a little bit and that caused the slug to move. Because I'm pushing on it a little bit. Okay, get back in there. There we go. It's just at such a tiny difference. I'm in the other slug now. Oh my. Okay, so this one was a fair bit out. Okay, we'll find the top. Go back to the first one. Okay. Now I'm going to move up to the next slug, which is one in the other can. I'm going to guess which one it is. Well, I'm using educated guess. I think I'm using educated guess. Okay, I'm trying to feel my way into the slug. Now the next problem is sometimes there's not much action. I think I'm trying to get my screwdriver to settle in the slot. Meanwhile, I'm actually turning the slug all over the place. Okay, so I'm observing the angle of the slot in the slug. Putting my tool in just that way. Oh, that's really unnerving. How do I know if I'm turning that slug? Like, what's unnerving is nothing's happening on the meter. Okay, let me change this around a little bit. Let me just do a little camera trick here. Okay, this might be a little more interesting. I'm just going to turn the radio down a bit. So I've done these two. This is the one that caused the most variation, but is it really a lot of variation? I'm guessing this is the correct next slug to do. Can you see this thing hanging out here? So what they've done is the slug goes into this coil form, and the slug can be a little loose. And so to tighten it up, they stuck a piece of plastic down like this, and then put the slug in. And this is the plastic here sticking out. That's what that is. You don't want to pull that out. The slug would be loose after that. So it's done. It's done. This is a little band. Oh, I'm pulling it out. I just said don't pull it out. Son of a gun. Maybe I push it back. Is it that loose? Wow. Yeah. See, maybe I didn't pull that out of the slug. It's just a huge amount of excess plastic here. Jeepers creepers. Okay. Oh, that's the wrong slug. Jimbo. That's how easy it is to get this wrong. Okay, I'm pretty sure I'm in the slug. Watching the meter now. There's no change. There's no change. Did I really move the slug? Okay, I can see I'm in the slot. Yikes. Nothing happening. So now my choice is to drive this slug a long ways and wait for the meter to change. Guess I'm in the wrong slug. Assume I never actually turned it. Let me turn it. Oh yeah, it's turning. We can't imagine that this is far out. It's just going to be a little out if it's out. So maybe it's the wrong slug. Okay, we'll try the other one. This is where things go downhill. This plastic is actually blocking the slug slot. Okay, I think I'm in there. Yep. Oh, I could hear that. Where's the meter? I can hear the change, but I don't see anything happening. Oh. There we go. Maybe these are way out. Or I'm doing the wrong slug, and even though I'm getting an effect, it's not. Okay. Yeah. I'm sure. Really would. I bet 50 cents this is the right one down here. Let's try it again. We'll turn it. We'll get bolder. Okay, I need to put a flag on this. I need a flag. I need a flag. Give me a flag. So you put a flag on the tool so you can count the number of rotations and be aware of how far you're turning the tool. Okay, we'll flag it up. There we go. Flag on board. Once again, we'll go in. Okay. No question, we're turning the slug. These slugs turn with zero friction. It's got to be why they've used these pieces of plastic. Okay. Now I see it's pointing at, what was that? That's 9 o'clock. 1, 2, just nothing happening. 3, nothing happening. 1, 2, 3, 1, there's nothing happening. Put it back. Oh boy. Well, the only assumption I can make is that in fact this is the next one that should be done. Down the road I may find out I got this wrong and have to redo it. Down the road is not very far. I get to it today. So this one. Actually, the sound is more, like I can hear the sound better than I can hear the Okay, let's just keep going. Now we're going to adjust 19 and 20. 19 and 20 are up on the tuning box. And I need to stop for a sec here. You know, I know myself, I can only do so much of this in a day. Well, I've left that camera image up in front here. So this is the tuning box, even though it's a little hard to see. Doggone it. Got images on top of images here. Well, you can actually see 19 and 20. And 19 is pointing there, and 20 is pointing there. Those are the two output terminals that I was using earlier. So I can easily locate these, 19 and 20. Okay. Yeah, I can only do so much with this kind of stuff before it's complicated because I'm talking for the sake of you, and at the same time I'm fooling around with the video, petting my cat, watching TV, everything under the sun. 19 to 20, adjust for maximum deflection on the meter. Okay, here we go. These ones are going to make a big difference, I suspect. Oh, I can't see it here. Way down in there. I hope these ones turn as easy as the others. Okay, going into one of them. Way down there. Okay, what's that meter doing? So it feels like the tool is popping in and out of the slug. Just hold this radio before it goes down. So I'll get a little piece of the slug. But you see, I've turned it. Oh, here we go. Come on, keep turning. Some of that up and down is because of me varying pressure with the tool I'm using. I'm expecting this to make a big difference. Oh my gosh, I can't tell if I'm turning the slug or not. That's got it. Stay in. Stay in. Oh, son of a gun. Turned it the wrong way by accident. Here we are. That's clearly a peak happening right there. Okay, that made a large difference. Kind of expected that. Now we'll do the other one. The other one, the slug is not sunk. It's right at the top, so I can see that I'm in. Reaiming the camera here. We're going sky high. There's the peak. Right on 8. I'll go back to the first one. Does each of these mutually affect each other? I'm in. Just a wee bit of an adjustment. That's probably made a huge difference in the operation of the radio. The last two I just did. Now the last one is A21. A21 is one of these two. It's the other one. A21, and this is a different kind of test I have to set up for. Okay, I'm going to stop for a little bit and just relax. Okay, the next test has a bit of a concern here, because it says DC probe to common point, no, to probe point C, or test point C, common to point D. So the problem with that is I would have two grounds attached to the radio in two different places. I have a ground from the signal generator and a ground coming from the VTVM over here. The VTVM has a ground on it for sure. It's this little green wire you can see. So you're putting two ground points in two different places on the radio. It doesn't sound good to me. So I think my best option, unfortunately, is to use the digital meter, which I do not like using in this kind of application, because I don't like looking at the flashing numbers. I like looking at a pointer. But I'm too scared to do what they're suggesting in there. Okay, so maybe I'll let her run. Let her run. In case there's some excitement here. So we're making a DC measurement. A small voltage around 8. What is it? It's around it's 2.5 volts. Okay, so we'll put this on the 20 volt scale. And what am I trying to do? I'm trying to adjust for zero reading. A positive and negative reading will be obtained on either side of the correct setting. So we want this guy to say exactly what it says now. 0. Why don't you come down from on high and have a better look at it. Okay, I'll keep the other meter in view. No, it's up on the screen. I don't need to do that. Okay, now we'll put this red clip lead on the red. Not that it matters, because we're trying to enable create a 0 here. This one here. Okay. Let's put these over here. Read again. What does it say? DC probe to point C, common point, and common to D. Well, it doesn't matter what I'm using, an isolated meter. Either one can go either place with this kind of test. So C and D. D is the junction of the two resistors I soldered in. And C, where is C? Where is C? C, C, there's nothing to clip onto with C. I got this whole set operating here. Turn it around very carefully until I can see C. C. So double checking where C is. Tricky in these photocopies to spot what it's pointing at. I think C. Got my phone in here. I'm gonna move my phone. Apologize if that's been interfering with the video the last little bit. C has to be that. Oh my gosh. I'm going to stick a clip lead up in there with the set operating. What am I going to clip on? I have to solder a test point onto the radio. Have to turn it off. Warm up the soldering iron. I need a test point. I can use this. Hold it with my fingers or I'll be upset when they burn. Okay, that'll work. Put that there. Need to freshen up the solder. Set is off. Yes, it's off. A lot of these soldering irons, the ground tip is grounded. The ground tip, the soldering iron tip is grounded. See, I've been in here too long. No no longer able to speak properly. Let me put it right on this here. Okay. Now, get this ready. Sure hope I got the right test point here. The right spot. Solder this on here. Some radios, these test points are... Oh, jeez, my phone just scared the test points are permanently in the radio. Oh, I can't hold still long enough. What's going on? It's rotating in my plier. Don't rotate. Nobody rotate. Yeah. Managed to see where that's going. So I'm doing all kinds of things wrong here. I'm rushing. That's the number one. To grab the hot end of this piece of wire. I'm rushing because it's almost 1 o'clock in the afternoon. Okay, calm yourself down. Do it calmly. You will succeed. Squeezing this tool like crazy now. Come on, I let go of the tool a little bit. There we go. It's in. Test point's in. Okay, back to where these clip leads go. So one goes to that test point. And the other one goes here. Okay, I think we're ready again. Power on. Give it the full power, of course, during this. And we're back to kind of the guesswork on which one of these to adjust. There's the voltage coming up. What did I do with my wonderful alignment tool? Here it is. How come it's not up at 8? It's going to slowly work its way there. It looks like it, doesn't it? I'm talking about this meter here. Maybe we better just wait till it gets to 8. Better just leave this thing running for a bit. Okay, I've given it a bit of time. It seems to want to hang around 7. I think we're going to accept that. How stable is this? Yeah. One of the things about alignment is you need to have it in your head. You're going to do it a few times. Okay, guessing now. Guessing on this one here. Attempting to turn that to 0. Wow, where'd the radio go? Okay, so we're right past the negative. Yeah, let's go back. That's the adjustment. Now, I'm going to turn the other slug in that same can on a counter, and that's the reason. Let's see what happens here. I'm going to watch a couple meters. I don't think I got it in. It's really... lunchtime is really what it is. But I want to finish this off because I have everything warmed up here. Got my head in the game. Okay, we're in the slot. The It's the one that didn't make much difference anywhere. Don't scare me, phone. For some reason, this one slug just doesn't seem to want to make a difference. Let me make sure I'm in. Darn piece of plastic's in the way. I can't see what I'm doing. There's a little bit of dust in there too. Oh my gosh, come on. Keep calm. Okay, I'm turning the slug. Turning the slug. Watching both meters here. So it's just no effect. It's really hard to explain. So we've done the alignment and the sound is gone from the signal generator. Not to say it's done wrong. We're still at 10.7. Let me vary it a bit and see what happens. Watch that meter. Was not watching the meter, so we get the maximum. It's a hair trigger. Right there. 10.707. And what happens if it's at 10.7? It's a very small variation here. That would be 10.7. Right there. Next thing to do is to try the radio. Okay, can we do it with all this equipment hooked up? I think so, except the signal generator and the sleeve has to come off. Do that too. Wow, that's my finger going on and off the sleeve. Okay, the sleeve is off. Everything went south at that moment. That's why we need to test this radio. I'm just going to take a piece of wire for an antenna. A short piece of wire should be enough. Pick up a strong FM station. Okay, we're going to put it on. There, turn this radio up. It's got a nice FM hiss. And tune away. That's an interference signal. I think that sound is that signal generator which I've had on. That's what it was. One of the things I've discovered in doing this kind of work is that the very last thing you do is you just listen to the radio and twiddle everything. that has worked really well for me. I think it's a slight improvement so far. And it's certainly not perfect. That's certainly not what it could be or should be. Let me stick another wire on here. A wire on each side of the antenna. there's a good station. Sorry for the out of focusness on the camera. What's that ugly hum? Okay, I'm going to get a copyright hit. How much volume is there? We're still turned way up. Okay, nothing completely solved here. Could be, 2-3 different problems going on, a little bit of alignment, a little bit of this, a little bit of that, and I got to get them all before everything's great. And like I said, maybe just fiddling with it. Once I get familiar with all the adjustments, where they are, and the like, I'll be fiddle ready. So I don't know how much video I got here, probably a ton. But thanks a lot for watching, and we'll carry on tomorrow. Doing more.